let's just slide to next week. I mean, we should
Yeah,
be
no,
able to.
that's the way it will always work. Am I talking? Okay, good. I got my microphone on. That's all good. Um, well, there was a possibility that I hadn't been talking. Well, it's
Senility
not.
sets in.
So last week we left off with player navigation. We're going to go back to that today. But when you download the game at this point, what you're going to see is some differences. Last week all we had was our dude walking around. Let me go ahead and restart the game. Relaunch it here. Now what you're going to see is I will check in the version that is slightly intelligent. In fact, this is the version we're seeing now. So right now what we've got is our dude walking around. Dude. And zombies coming in. Now, last week I also showed you the limit. So now you can see that the limit is something reasonable as far as the world size. Last week it was this little tiny red rectangle. And this is still just a debug feature to show you the limits of the world. The other thing you're noticing is these guys are following me around. I don't know if you are noticing that, but they are trying to kill me.
So we have limiting the player's movement to the box. We have spawning enemies, and then we have pathfinding. They're right. They're trying to.
We do not
follow
have
the player.
pathfinding. Right now, what we have is the nickel version of AI.
The nickel version.
This is, yes. Okay, when I make a joke, let's let it kill me. I make a joke, but I can't stress enough. When you're making a game, do not spend $1 if you can spend a nickel. And what I mean by that is, don't do the hard solution first if there's an easy solution available to you. Now, I will describe this easy solution, and you will be amazed, I think, at how simple it is, and yet the fact that is you see me playing here. Let me start it again. Just observe the way they behave, first of all. You'd think that this might be like sort of some kind of tricky algorithm or something, right? I mean, they're giving chase, they're changing direction. No. This is about as simple as it gets. The way this works, I spawn the enemy off screen. I always do that so they don't pop into view. And then I tell them literally, this is how far away I measure the distance, and then I do a transition where I simply calculate the time that transition takes based on the distance. So if they're 500 pixels away, I choose a random speed of say 100 pixels per second, and then I divide 500 by 100, I get 5 seconds. So my transition will run for 5 seconds, and they merely animate and then go in a straight line. The transition just merely moves them from this point to this point. Very, very simple. And when they get there, if I'm not there, if they get there unharmed, unshot with an arrow, and they don't run into me, the thing just says, oh, I got to the end, I'm done, and then it runs the same routine, and it measures the distance to me again, and they start moving again. So all it is one transition complete, do another transition, and then I just simply update the animation that's playing based on the angle they're supposed to be moving in, and that is it. I mean, it's just like 5 lines of code to do really super simple AI where they will try to chase me down. And the only other thing that's going on here is I put a counter in here that says only allow this many zombies to be in the game at a certain time, or enemies. And currently the number I think is 10, which felt like a good balance for doing the demo. So when you get up to 10 enemies, I'll just let them come in without killing me here. I can manage that. As you can see,
It's like a chase
10
game.
enemies on the screen at a time, that's plenty. I mean, until I get them all wrangled into like a circle here, right?
You know what's funny is back in the day, we're talking, I don't even remember, like maybe early 80s or something. I had a Texas Instruments, a TI-994A. Okay, you can look it up, Google it. And
I had two.
I know, yeah. I'm talking to the people who are like, what? What did he just say? What did he just call me? You know, there was trade magazines at the time. You know, paper. They used to write things on paper, and they had these programs in it, and one of them was a game where you were in a parking garage, and there was some zombie chasing you, right? And all the cars, the walls, everything were just blocks on the screen, and you were a colored block, and then there was another colored block that would start off on the other side of the screen, and it would basically make its way to you, but it was clear that it was navigating based on where you were. So if you were on the complete opposite side of the screen, if you moved to the top, this thing would start navigating across the screen to the top, and then if you moved down, it would start navigating down, right? So, but I remember the code for that being like super simple to follow. And so what you're describing here is basically the same principle, 20, 30 years later.
Yeah, no, this is the thing about games. I mean, yes, the answer is yes. What you're saying is absolutely true. And when it comes to games, the mechanics have all been done. Somehow, some way, every mechanic that you see in a game has been done. It may have been coded a different way, etc., but there are only so many ways under the sun to express an idea, and there are only so many ways, and when I say that is, I'm not talking about the aesthetics. Your game had squares, this game has, nicer looking zombies. But the premise is the same. Enemy moves towards you in some fashion, right? The algorithm is used. There's only so many algorithms out there. So people learn these things. You can just apply it over and over to new games and new variations, and certainly create new experiences. But the guts are the guts. That's you learn them once and you use them over and over.
Yeah, gravity always pulls down.
Yeah, exactly. I'm looking for the code because I really wanted to show it to you. Enemy manager. There we go. Let me find it. We were just talking about it. I might as well just point it out to you. Enemy move to player. Here it is. So there's a function here in the enemy manager called move to player. Let me make it bigger so you can see it. And basically what it is, it's a method, if you will, a function that I attach to the enemy. So I say function enemy dot move to player, and then it has the argument self. So later I can call it like this, enemy move to player. But the other thing that it lets me do is it lets me pass in enemy as the onComplete as long as I say enemy onComplete equals move to player. Now I'm going a little fast, so I'll explain it in a minute. But let's look at the actual code first. First two lines, totally boring. Is the game running? Did the enemy get deleted since the last time I came in here? If so, don't do anything. These two lines are just basically keeping you from running when the game's not running, or trying to do something when we no longer have a valid enemy to operate on. But assuming we get past that, all we do is we calculate a vector from the enemy to the player, and that's what this is. It's just a table with two entries, x and y, in it. And then we take that and we pass it into vectored angle, which is, this is math 2D, and basically what I've done is I have localized the function and given it a name that I can remember. So I call it vector2angle. And that takes the vector and converts it into an angle. And then I use that angle. First of all, I store it in the enemy because I use that other places in the code, which isn't really important at this point. But I keep track of it because I'm not really rotating the enemy. What I'm doing is choosing the right animation to play. So I could have said rotation like this. I go changing code and probably messing up the game, but I don't really want to rotate the enemy. In fact, if I ran this right now, this would be wrong. Let's just see what's going on here. Now we run it, and my zombies are all goofed up because he's rotated. So we talked about this before, but all the players, all the animations in here, they don't rotate. What rotates is the actual playing animation. The animation itself plays in such a way that it looks like you're rotated. So anyways, then I calculate the distance, the length of the vector. So I got a vector, which is just, I subtracted the distance between the two, gives me this vector. I calculate the length, and then remember how I said that I give like a random speed to the zombie? So I say here, speed is equal to your current speed if you have one. But if you don't have one, call math random and get a value between 75 and 150. So that's going to be your pixels per second speed. That's how many pixels you move in a second. And then I store it on the player. So, and then
that's a nice little touch too, because then not all the enemies are like headed at the same speed to the player.
Right. Yeah, I mean it totally throws you off, especially if you're like used to dealing with slow zombies. And then suddenly one comes in, he's booking it twice the rate of the last guy. You're like, whoa, slow down, coachies. And the cool thing is as they're chasing you, once they've got a speed, they don't change their speed. They're going to continue to run or move at that rate until you kill them or until they get you.
I'd love to hear that in a zombie movie. Whoa! Slow down, coaches.
Slow down there, coaches. Whoa. But the algorithm we need here is we need to calculate the time our transition is going to take, and that is simply this does not need to be in here. That is simply the speed, the length divided by the speed, then multiplied by 1,000 because we need it in milliseconds, not seconds. So we get, this is seconds, and then we need to make that in milliseconds. We multiply it by 1,000. So it's in the right, I can't think of the right word here.
Unit? No.
Measure. Anyways, doesn't matter. So we need 1,000 times the length divided by the speed, and that's it. And then all I do then is I make sure that it's playing the correct animation based on the angle that it's facing, or supposedly facing. And I did air quotes like you could see me there. And then I do a transition. Okay, so I transition self, which is the enemy, and I tell it to go to where the player is. I don't even use the vectors here. All this vector math here was so I could calculate the time. That's all I needed. I needed to get the length of the distance between them so I could measure that in pixels and then divide it by my pixel speed to get time.